All right, back to our employee example. We have applied a couple of principles of object-oriented programming, encapsulation and abstraction. But this implementation still has a problem. What if I forget to call this or these two methods? Our employee object will start in an invalid state. The base salary and the hourly rate fields are going to be 0. Let me show you. So temporarily, I'm going to make the base salary public so we can quickly read it for this demo. Before we calculate the wage, let's print employee.base salary. We run the program and we see 0. All right, now let's remove this line. We don't need it anymore. And let's make this field private. So here we have a bad implementation because whoever is using the employee class has to remember to call these methods in order. This is bad design. We don't want to force the consumers or the clients of our classes to use them in a particular way. This is like having a magical remote control that forces you to press A and then B before you can change the channel. That's really strange. So we want to make the interface of this class as simple as possible. We want to reduce the guesswork. How can we do this? Well, at the time we create this employee object, we want to put it in an initial valid state. So we want to pass these values over here. Now here we have a compilation error. So let me temporarily remove these arguments. We're going to create a constructor in this class. A constructor is a special method that is called when we create a new object. Look at this line. This looks like we're calling a method, right? Well, actually, we do have a method by this very name in our employee class. We didn't create it, but the Java compiler automatically creates this method, and this method is what we call a constructor. It's used to construct or create a new employee object. The job of this default constructor is to initialize our fields to their default values. So numbers are going to be 0, booleans are going to be false, and reference types are going to be null. So back to our employee class, let's create a constructor. After we declare these fields, we declare a constructor method like this. Public, this method is not going to have a return type, not even void. Here we should type the name of the class with the same capitalization, exactly the same. So employee, we add parentheses. Now here we want to have two parameters, base salary and hourly rate. So now we have a custom constructor, and Java compiler is not going to create the default constructor for us. So in this constructor, we want to initialize these fields based on the values that we receive here. Now, there are two ways to do this. One way is to write code like this. That base salary equals base salary. However, with this implementation, I can still pass a 0 or a negative value as the base salary. So our employee object will start in an invalid state. So here we should use the setters that we created. These setters will throw an exception. So if we try to create an employee object with invalid values, our program is going to crash. We'll never have an employee object in a bad state in memory. So back to our constructor, let's call set base salary, and we give it this value. Similarly, we're going to call set hourly rate, and we pass that here. Now back to the main class. Here we have a compilation error because our employee class has a custom constructor that expects 2 arguments. So we're going to pass 50,000 and 20 here. Now this line is getting a little bit too long, so I'm going to break it down so you can see clearly. All right. Now we no longer need to call these methods in order. So let's delete these 2 lines. Now our main method is even cleaner. It has only 3 lines of code. So we use constructors to initialize our objects. If we don't create a constructor, the Java compiler will automatically create one for us. This is called the default constructor, and it will initialize all the fields to their default values. Now, one last thing before we finish this lecture. Look at the members of the employee class. So we have these 2 setters and the calculate wage method. Let's assume that once we create an employee object, we don't want to change its hourly rate or base salary. So once again, we can apply the abstraction principle and hide these details. Back to our employee class. I'm going to make this private. We're only going to use it inside this class. Once again, let's make this other method private as well. Now back to the main class. Look at the interface of the employee object. It's very simple. It only has a single method. This is a beautiful implementation. This is object-oriented programming in action.